Hi everyone. Here in this session we are going to learn how to sum two polynomials given by user. So this program is going to be a little bigger than my usual programs that I have done till now in this series. So what I would do is I would break this program into two video sessions. And in the first session what we would do is we would just talk about how to get user input, that is the two polynomials from the user, and then print the polynomials on the console. So that would be our agenda for the first video session, and in the next video session we talk about how to sum up two polynomials stored in arrays. So that would be the agenda for the next video session. So we would start with getting the user inputs and storing them in some data structure, and that data structure would be an array of structures. Each term of polynomial contains two bits of data. One is coefficient and another is power. And for storing each term of the polynomial, we would declare a structure data type. So let us start with it. Let us declare a structure data type. As you might be knowing, that structure data type is required to store heterogeneous data. So here we have two bits of data for each term. One is coefficient, other is power. So for that we are declaring a structure data type. And let's say the coefficient might be fractional value, so the data type would choose is float, and let us call it as coef, and the power term would be an integral data, so it would be int. So here is our data type, which of variables of which would be required for storing the terms of the polynomial. Now the sizes of the polynomial, that is the number of terms of the polynomials, would not be known before runtime, because this would be provided, the polynomials would be provided by the user. One thing we can actually do is to allocate a large static array, but in that case what would happen is either there would be wastage of memory if, say, we allocate an large array of 1000 size and the user only wants to add up polynomials of size 2 and 3, then there would be huge wastage of memory. And in another case, user might want to add polynomials of size, say, 1001 and 1002. In that case an array of 1000 size would not be sufficient, so our program would not be generic enough to handle all scenarios, and in another case there can be wastage of memory. So we would go for dynamic allocation of the structure array, and first thing that we would ask the user to enter is number of terms of the polynomial. So we would start with prompting the user to enter number of terms in first polynomial, right, and would store it in a variable, say size 1, and another variable would require to store size of the second polynomial, scanf %d ampersand size 1, and again we would prompt the user to enter number of terms of second polynomial, and we would read it and store it in the variable size 2 that we have declared for the purpose. Now the dynamic allocation part. Here what we are going to do is we are going to use calloc function. Calloc function allocates a memory dynamically, and then also it initializes the memory with zero values. So all the bits of the memory that would be dynamically allocated by calloc would be assigned a 0 value, and that is required for a purpose in this program. We will discuss about it later. And the calloc function would return a pointer to the dynamically allocated memory. So to store the pointers, we would declare two variables of struct polynomial polyterm pointer type, struct polyterm pointer type, and we would call it as, let's say, poly1, which would store the pointer to the first array, and poly2, which would store pointer to the second array. Now in poly1 would store the pointer returned by calloc. As parameter, calloc takes first parameter as the number of terms that we want to allocate. So here the number of terms in first polynomial is stored in size 1, and the second parameter is the size of each element. So here each element of the array would be of type struct polyterm, and the size of this data type can be given by using size of operator. Now calloc is going to return us a pointer to a void pointer to this dynamically allocated memory, and we would typecast it to struct polyterm asterisk. Right, so void pointer is getting typecasted to struct polyterm pointer. Similarly, for the second polynomial, would get a dynamically allocated memory and store it in poly2, the address of it in poly2. The size is size 2. Right, now we have this dynamically allocated arrays pointed by poly1 and poly2. Now it go for reading the terms from the user. For that we would write a function, and let us call it as, so it is not supposed to return anything, let us call it as read polynomial. And to it we are going to pass the pointer to the array in which that polynomial would be stored. So the pointer to the array would be of type struct polyterm asterisk, and let this parameter be called as poly. And one more thing we need to pass is the size of the array or size of the polynomial into it. Here in a loop we are going to ask the user to enter each term of the polynomial, and as there are as many terms in the polynomial as is the value of size parameter, so we would have a loop which would run from 0 to less than size. Now within this loop we are going to prompt the user to enter a term of the polynomial. So printf enter power of, let us first get coefficient because that is the natural order, coefficient of term %d. So we want to prompt to the user like this, enter coefficient of term 1 enter coefficient of term 2 like that. So in place of %d we are going to print the term position. So the term position would be given by I plus 1. When I is 0 at the first iteration, here we want to print enter coefficient of term 1. When I is 1, then we are going to print enter coefficient of term 2 like that. So here that's why I have taken I plus 1, and after that coefficient is taken. After that we are going to take power of the term, and we are going to store it in ith element of the array. So coefficient is of type float, so %f, and we'll have to store it in the array, ith element of the array. So ampersand poly I, that is ith element of the array, and in that coefficient, right? So we are going to read and read the coefficient, and we are going to store that value into the coefficient field of ith term of the array. Likewise we are going to read the power term, and as power term is of integer type, so %d, and here we'll have to write power. So with this we would be able to read the terms of the polynomial that user wants to enter. Now we would use this method in main function, we would call it. So before main function, let us declare it, but it is not mandatory for code blocks ID. For other IDs it might be mandatory. So anyway, for making it a generic purpose program, let us declare the prototype before main function, in which we are going to call it. Now we are going to read the polynomials one by one and store them in poly1 in the array pointed by poly1, and in the array pointed by poly2. So first of all we are going to prompt the user to enter terms of first polynomial and we would call this read polynomial function. To read polynomial we are going to pass the pointer to the first dynamically allocated array and the size of the first polynomial. Likewise we are going to read the second polynomial from the user. So you'd again do this. So we are copy pasting, and copy pasting is a great tool for software engineers. If you are good copy paster, you can become a very good professional. So learn this technology. Alright, so anyway, poly2 and size 2. So we are reading the second polynomial from the user. Hopefully everything is fine till now. Yes, I think it has built correctly. Now we would need to print the polynomials on the console. So we are going to print whatever user enters, we are going to print it in a formatted way on the console, and as well as we would need a logic to print the result on the console. So for that we would declare another function and we would call it as print polynomial. Very intuitive names. Probably you can think of more relevant names, but for me print polynomial is relevant. and this is going to take these two parameters only. Right, and in this we are going to loop for as many times as there are number of terms in the polynomial. We are going to print and a sample of how the polynomial would look on the console is like this. If 3x square has to be printed on the console, say 3x cube has to be printed on the console, then it should look like this. 3.0 x cube would be represented like this. We would use this symbol, I think it is called as caret or something. So x caret 3, then let's say second term is 5x square, so 5.2x square, 5.2 x, this caret sign, then 2. Then let's say the third term is a constant term, let's say it's 10.4. So the polynomial should appear on the console like this: 3x cube 5.2x square plus 10.4. This is how it should appear on the console. So this is the purpose of this function. So here we are iterating from 0 to less than size, and in each iteration we are going to print one term on the console, right? So for that, first of all, we would print the coefficient of ith term. So printf %d, then coefficient of ith term is contained in this array, and it is fractional, sorry, so it is fractional, and we want to just print the first term, one term after decimal point. So for that we would use this format specifier .1f. so this would just print one number after the decimal point. Now we'd have to print x followed with a caret sign and then followed with the power term. So in place of this %d, we want to print the power term of the ith power field of the ith term of the series. Right, and then we are going to print this plus, and there is an anomaly here. The last term is not followed with a plus. So except the last term, we are going to print a plus after every term, right? So to avoid printing plus in the last term, we are going to have a conditional logic over here. It might not be the only way of doing it, but this is one of the ways that we would check with if I is equals to size minus 1, that represents the last term, is not equals to size minus 1. So if it is last term, we are not going to print plus, and if it is not last term, then we are going to print a plus as well. Printf a plus. Right, and one more thing that we want to do here is if the power term is if the coefficient is 0, we are not going to print that on the console. That I am doing it for a purpose that would be clear probably in the next video session, in which we would skip all the terms which have 0 coefficient. And that is also one of the reasons why we used calloc function. We wanted all the terms to be initialized with 0, and that's why we used calloc function over here. So we used calloc function over here, right? And that was the reason that we wanted it to initialize the terms with 0. Well, so if the power term, if the coefficient is 0, we are not going to print it. So if poly 1 I dot coefficient equals to 0, we would break out of the loop. Means the coefficient 0 would just represent that as it is end of the polynomial. We didn't have to print it. And here our assumption is that the user would enter in this program, the assumption is that the user would enter the terms in descending of order of their power values. That is one of the assumption, and another assumption is that user would never enter a term with 0 coefficient. That is another assumption assumption in this program. Well, we have defined this function. Now we are going to use this function to print the polynomials that user has entered and on the console in a formatted way. So for using the function, we are first going to declare its prototype before the main function, and then we would call it from the main function, and to it we pass the pointer to the first polynomial and the size of the array and the size of the array in which first polynomial is stored, and also the second polynomial. So the second polynomial is stored in array pointed by poly2, and the size of the second polynomial is size 2. Before it, we are prompting to the user polynomials entered by you. And in between these two polynomials, let us have a new line. Right, now it is time to test our program that we have written till now. So I think it has compiled correctly. Now let us run it. Enter the number of terms in first polynomial, let's say 2. Enter number of terms in second polynomial, let's say 3. Enter coefficient of term 1, let's say 3.4. Power of term 1, let's say 3.4 x cube. Coefficient of term 2, let's say 5.6. Term 2, let's say 2. Enter coefficient of term 1 of second polynomial, let's say 4.8, and power is 5, let's say 6.3, and power is say 2, and a constant term, let's say coefficient of third term is a constant, let's say 4.8, and the power term is of the constant term would be 0. Right, so this is how it is represented on the console: 3.4 x cube plus 5.6 x square, 4.8 x to the power 5, 6.3 x to the power 2, 4.8 x to the power 0, that is constant. So the program has run very fine, and these are the functions that we are going to use in the next video session for accomplishing our task of adding two polynomials. So now let us quickly discuss about the size of the result that we may get by adding two polynomials of say size 1 and size 2. So the maximum size of the resultant polynomial would be the summation of the sizes of the each polynomials, and that would happen in the case where the two polynomials does not have any term having same power with that of the another polynomial. So let's say if the polynomials are like this, 3x cube plus 5.2x square plus 10.4, and another polynomial is, let's say, 3.4 x to the power 5 plus 6.8 x to the power 1. So if these two are the two polynomials, then there is no overlap between the powers of the terms, and the resultant polynomial would contain 5 terms, that is size 1 plus size 2. These would be the number of terms in the resultant polynomial. So maximum number of terms in resultant polynomial can be equals to size 1 plus size 2, and the minimum number of terms can be anything. If that would be anything means the number of terms of any of these two polynomials, probably the one which has a greater number of terms, that would be the minimum size of the resultant polynomial. So we'd have to handle the scenario in which we can have maximum number of terms in the resultant polynomial. So for that we would declare an array of size 1 plus size 2. In that we are going to store the result. So for that we declare a pointer variable and name it as result poly, and to this we are going to store a dynamically allocated arrays pointer, size of which would be equals to size 1 plus size 2, size 1 plus size 2, and each term of the polynomial would be of type struct polyterm. So size of struct polyterm gives us the size of each element, and now we have typecasted it and stored it in result poly. So this would be the array in which we are going to store the result. So in the next video session we talk about the algorithm of summing up two polynomials that we have stored in this dynamically allocated arrays pointed by poly1 and poly2, and we take it forward. We are going to use this this print polynomial function to print the result on the console as well. So thanks for watching, and watch the next video of this series, link of which I would provide in the description section of this video. So keep watching all these videos and improve your programming skills. Thank you. Thanks for watching. Bye.